Hi, it's Carly McAvoy. I'm talking about multiplying and dividing rational expressions. To multiply rational expressions, you can factor first if possible, cancel the common factors, and then multiply. To divide rational expressions, you first find the reciprocal of the second term, change the division to multiplication, and then follow the steps for multiplication. That should sound familiar because that's how you do fractions. And these are just fractions. So in the first example, example A, it may be easiest if you list out the factors, but that's not how I would do it. But maybe for you it is. I'm listing it out. I probably would not do that. But if I listed out the 5 and 6 different p's and then 18, I say is 2 times 9. I said 2 times 9 because I could see a common factor of 2 between 18 and 10. And then 10 I listed 2 times 5, and then the first p and then 2 more p's that were on the bottom. And then I can cancel out everything that I can. So the 5's go and the 2's go. I have the 9 left. And then up on top I had 6 p's. These 3 p's will cancel 3 of those. And there would be 3 left. So we have 9p to the third. On the bottom we don't have anything left. We really do have a 1 left, but we don't need to write it. So 9p to the third over 1 would be equivalent but not necessary. In the second example, it is multiplication again. I'm going to factor all of that stuff and then simplify. And I'm not teaching you factoring here, so if you have trouble with that, go back and review those factoring videos. In the first one I would take out a common factor of y, leaving y minus 4. And I'm not going to factor that. I could have written that out as y times y times y, but again, I wouldn't do that normally. And then here I can factor using a box method or whatever method you use to factor trinomials to get y minus 5 and y plus 4. And y squared minus 16 is a difference of squares, and that's y plus 4 and y minus 4. It doesn't matter which one you write first. Now you would go back and cancel what you can. I can see that the y plus 4's would go and the y minus 4's would go. As long as one's on top and one's on the bottom, you can cancel. That y minus 5 is going to be left over for sure. And over here, this 1y would cancel one of these on the bottom, but it would leave 2. So I'd have y minus 5 over y squared. And remember, we can't cancel anything out of this. You can't cancel part of a binomial. The whole thing or nothing. You can't go in and take pieces of it. Okay, and then for division, we're going to do the same thing. The first example we had divided by 27 over k to the third. And I'm going to flip that, k to the third over 27, and change that division to multiplication. And then I'm just going to simplify. I can see that 9 goes into 18 twice, and it goes into 27 3 times. That's how I got the 2 over 3. And then I have more k's on top than on the bottom by 1. I could take 2 of these k's and cancel 2, and I would have 1 left over. So that's my answer, 2k over 3. And finally, the last one, I'm going to say this. If I was given this problem, I wouldn't rewrite that and then change it. I would just change it in the first step. So I wanted to say that that's okay. So if you were seeing this in the book or on the computer, just go ahead and write it down as change your division to multiplication and flip that second term. That's the reciprocal, 24 over 5x minus 35. This can't be factored. I could factor those. I did write those out, 5 times 3 and 3 times 8. Maybe you don't need to do that to see that. And then I can factor this by taking out a common factor. That's just reversing the distributive property. Take out the 5 and I have x minus 7 left. What can I cancel? I can cancel the x minus 7's. I can cancel the 3's. And that's it. I still have an 8 in the numerator, and 5 times 5 on the bottom is 25. All right, that's it. Have a great day, and we'll talk to you next time.